In this video, I will go over the steps I typically follow for factoring quadratic expressions. So we're given this quadratic expression here, 4x squared minus 25. And the first step would be to factor out the GCF. Well, my first term is just 2 times x times x. So the factors of this are 2 and x. My next term is negative 25, so its factors are negative 1 and 5. They don't share anything in common. And my leading coefficient is positive. So on to step 2, check for two patterns. The first pattern is a binomial pattern. The second pattern is a trinomial pattern. I only have a binomial here, so unless it's a difference of squares, I'll move on to step 3. Is it a difference of squares? Well, 4x squared is 2x quantity squared minus, and 25 is 5 squared. So this indeed is a difference of squares pattern. So if I have this memorized, I can just finish this off with equals. I'll have my first linear factor, my second linear factor. I'll put a 2x here, I'll put a 5 here. I'll put a 2x here, I'll put a 5 here. And then I'll either put a plus here, a minus here, or a minus here and a plus here. I'll go ahead and put the minus here and the plus here. Move on to step 3, factor any quadratic factors. My first factor is linear, it's x to the first. My second factor is linear, x to the first. I can skip step 3. And now on to step 4, just do a quick check. Did I forget to factor out any common factors? Well, my first factor, the terms are 2x and negative 5. They don't share anything other than 1. And my coefficient here is positive. In my second term, or my second factor, I should say, the two terms, they don't share any common factors other than 1, and my coefficient here is positive. So that all looks good for no GCFs forgotten. Do my factors multiply to the correct product? Well, I have difference of square pattern memorized, and I have conjugate factors memorized, so I know it does work out, but I can draw my area model just to do a nice full check. So I draw my rectangle, and I'll make it 2x minus 5 and 2x plus 5. Find each individual area. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 2x times 5x is 10x. And 5 times negative 5 is negative 25. Do the quick check. Do all 4 of these areas add up to my original product? And that's not underlining for some strange reason. Okay. 4x squared is right there, negative 25 is right there, and negative 10x plus positive 10x is 0x, and there is no linear term here. So it would be 4x squared plus 0. It's kind of sloppy. 4x squared plus 0x plus negative 25 if I was going to write this with every term and write it as addition. So that works out. Go ahead and check my diagonal products here. 4x squared times negative 25 would be negative 100x squared. And 10x times negative 10x, multiplying this way, is indeed negative 100x squared. So it all looks good. What if you didn't know the pattern? Well, you can still factor it out. It just take you a little bit longer if it's not memorized. So we'd still check for the GCF, no GCF. Now we have to factor in a quadratic factor. So if we didn't know the pattern, and if we just had the 4x squared minus 25, we could make an area model for it, fill in what we know. So I put my quadratic term in this rectangle, put my constant term in that rectangle. I know this is going to be an x term and an x term. To find these two coefficients, I know that the value of b in ax squared plus bx plus c, I know b is 0 here. There's 0 x's. If we write it out, you can see it right there. So I know b must be 0. But I know a times c, the leading coefficient times the constant, I know that equals 4 times negative 25, which equals negative 100. I just have to think of two numbers, looking for two numbers that multiply to negative 100 but add to 0. Well, because they add to 0, that's a pretty easy place to start. We know they're going to be opposites. If we ever have a sum of two numbers equaling 0, the two numbers must be opposites. So the two numbers that multiply to 100 are 10 and 10. This must be 10 and negative 10. I can make one of these 10, the other one negative 10. And now I have my area all filled out, same area I had here when I did my check. And I just play the GCF game to get my two factors. I'd pick my top row here. I'd say we'll do 4x squared and 10x have in common. Well, they obviously have an x as a factor in common. 4 and 10 both share a 2. They're both even numbers. If I know this is 2x, I just do the length times width equals area game now. Length times width is area of this square, so 2x times 2x is 4x squared. I know 2x times something is 10x. That'd be 5. I know 5 times something is negative 25, that's negative 5, and I know negative 5 times 2 is negative 10x. So I would still get 2x minus 5 quantity times 2x plus 5 quantity. So that's how I would factor it. If you know these two patterns, it's going to be a lot quicker. If you don't know them yet, I suggest getting them mastered and memorized, and let me know what questions you have.